This is basically a quick intro to what's HTTP3 actually, what it's used for, what's the use cases we have for today, and how do you turn it on in Envoy? How can you use Envoy for serving HTTP3? Okay. All right. So first, a bit about me. My name is Adam Sayah. I'm a field engineer at Solo. I help my customers and prospects basically with all their API gateways questions and service mesh and so on. So if you guys want to have a chat, slack.solo.io or Twitter. Here, I want to give a big shout out to Baptiste Collard, one of my FE colleagues that worked on HTTP3 blog. He has really good content there. It has a lot of extra data if you guys want to go deeper in this subject. But for most of these slides, apparently I get a lot of inspiration from this blog. Okay, so what we're gonna do, we're gonna go through a brief history of HTTP3, basically why all this evolution and basically where we are today with HTTP3 and what's the nuances there. So it's gonna be what's the differences between HTTP1, HTTP2, and HTTP3, and then we're gonna talk about QUIC, which is basically, spoiler alerts here, is basically the kind of protocol that's used for HTTP3. Then we're going to look into how we can turn on HTTP3 in Envoy. Then a quick slide on performance, kind of comparison with real data compared to actually what people are seeing in terms of usage plus performance, H2 versus 3 and so on, and just a quick conclusion. So I'll probably take about 15 minutes for this presentation. Okay, so let's start here. A quick history of HTTP. So HTTP is pretty old. I mean, we're talking about 30 years of existence now. It started with we have a good ambiance too. So HTTP started with a basic protocol to allow us to access data, but was way too limited. We were able to make calls, get calls to get data, but that was pretty much it. Now, things that are lacking at that time was basically differentiating in terms of header support for multiple use cases. Kind of the most common use case for header support is, and we need headers for cache control, right? If we have any data that we need to cache somehow, we need to activate certain mechanisms based on different behaviors, headers are kind of the way to go. And this is what came out in HTTP 1.1. We added HTTP header support to basic HTTP, and that was fine. The thing is, with HTTP, the basic version, 1 and 1.1, it uses one connection per kind of request. This is not scalable, meaning if you make a lot of requests and services are already consuming a lot of traffic, it means that's going to create a lot of connections that will stress your network a lot. Now, Google, thinking about a solution to this problem, they came up with different things. And I think the first one is Speedy, right? The Speedy protocol allow us to basically do multiplexing of different connections on different requests on the same connection, right? This is kind of the first step to what we know in HTTP2 using multiplex connections, right? So that was limited to only couple, I think only 8 or 9 connections on the start, really basic. But also they worked on a different thing, which is LPN that we still use today. Meaning, when we negotiate TLS at the same time, we actually can define which protocol we can use. In this case, before, LPN will allow you to, if there is any enhancement in terms of connectivity, something we can turn on, as part of the TLS negotiation, we'll be able to have this data and retry the request or upgrade the request for a better protocol. And actually these two together are kind of the first steps to what HTTP2 is, which is a way to multiplex connections again, and it's way quicker than HTTP1, right? If in comparison, I don't have any diagram here, but if you look into comparison between HTTP1 and HTTP2 in terms of performance, we are talking double, triple sometimes, right? So this is really important and was a big step into the right direction. Now, HTTP2 is great. The thing is, we live in a world where it's not always, we don't have always stable connections. If we talk about we are all on our phones. We are all, on bad networks. This is example here. For example, I need to. Yeah, there's no Wi-Fi here. But we're living in a world where there is no stable connection, stable networks there, right? Maybe during our lifetime we're gonna get to this point. I'm not sure. Maybe our kids, but at this point we need to figure out an option, a solution to make this more efficient in kind of bad networks and also in good networks, right? So we need a solution to help us having the best of user experience in all situations. And this is what actually is the premise of why HTTP3. Okay, we have good performance with HTTP2. That's great. That's based on TCP. It's fine if your network is good and all that stuff. But real world use cases need something more like HTTP3. Now, why? We're going to get to that later, so no spoiler for now. HTTP 1.2.2 helped a lot into a lot of problems that we had with HTTP 1. Mainly, the head of line blocking. It improved it, didn't fix it. Head of line blocking in HTTP, meaning if we are sending some traffic through TCP, right? I'm sending packets for my request and so on. If there is a problem, there's one packet lost for some reason, then we're gonna have to send everything back, right? And this is not efficient. HTTP2 helped that a bit. I have a slide on this, where with multiplexing things get better, but still are not perfect. And this is one of the areas where we need to improve. And HTTP1 to HTTP2, basically header compressions too. This is very important. The amount of data we get in headers is crazy. So having header compression also make requests better and faster. Now, TCP head of line blocking is, again, one of the main use cases for why we need HTTP3. First of all, head of line blocking, as I explained it in HTTP 1 and 2, even if you send different type of packets, the problem is like if there is any problem during this transmission, we have to resend everything back, right? Now with HTTP3, now only the packets that are lost can be resent, right? So that means from a performance perspective, now we don't need to resend everything. And this is a big improvement in a lot of things. Like imagine you are downloading something, imagine you are connecting to a game, imagine anything else. Like you are losing one packet because of bad network. Imagine all the latency that can be involved into resending everything every time, right? Especially if we talk about real-time data and things like that. Okay? So this is kind of one of the most important things that HTTP3 is helping with. Now, there's other things. Also, one thing that is in HTTP3, TLS is embedded. TLS 1.3 is embedded within HTTP3, meaning obviously you can't have plain text connection anymore first, but from a security perspective, that's great. And also, that's improving in terms of like, you don't need the TLS negotiation phase after the TCP connection, all that stuff. It means you're gonna connect way faster to your backend. And we're gonna get to this in a second. Another thing that is really important is basically, actually, the biggest thing here is that HTTP3 is based on top of UDP. This is kind of pretty weird because, I mean, UDP, we know it for protocols that are kind of flexible with packet loss. If you're doing like streaming of videos or thing like that, that's where, UDP thrives. But we never seen it for something more where we need something reliable. And actually, what HTTP3 is adding on top of UDP with the QUIC protocol, QUIC for quick UDP internet connections, it will help to add. It helped to add basically what we used to have in TCP in UDP, like congestion control, reliability, and so on. Also, on top of that, there's new feature for connection migration. Connection migration is really important. Imagine, I think that's a use case for everyone here. You are at home, you have your Wi-Fi, you're fine. You're on a Zoom call, whatever, and then you have to go outside for some reason, right? Then you are in your connection, and somehow everything drops. Why? Because you have to switch to a different network. Connection need to switch to different things. We have to restart all the connections. That gets, you feel it. There is something going on there. Where if you have connection migration, meaning like if you are actually on top of, basically you're already running HTTP3, if you are switching networks, switching traffic, going somewhere else, that would just automatically switch to that, to the new way of connecting to your service, basically. And so if you are in the same example I was talking about, if you are on your Wi-Fi and then you go outside and you are now on your data on your phone, you'll see no loss, no packet loss. You can see there everything gonna continue to work perfectly as it used to be. This is a huge. So in terms of performance, in terms of comparison, like when we try to talk to a backend using, let's say, the basic use case where we talk about, just HTTP with TLS 1.2, you still have the TCP first connection, and then we'll have the TLS 1.2 negotiation, and then on top, and after that, we're gonna have the request itself, right? So in terms of like the time we get to make the request, this is way longer than actually at first with TLS 1.3. We have one less stop there, so it's gonna get way faster in getting the data. But the important thing is actually in HTTP3, where QUIC itself, like the protocol that's actually connecting to your backend, contains TLS embedded. So as part of the first negotiation, as part of the first connection, you are already TLS connected. Everything is ready to just start sharing data. Plus, now if you think about a lot of good things we have in TLS, for example, session resumption, that's something we use often. It means that if you already establish a connection earlier, you don't even need to do all this. You're gonna go straight to sending data because you already have a ticket into the session resumption. So in terms of performance, with QUIC, we see back and forth between client and server. If there is no prior connection, but if there is a prior connection, there is nothing. So in terms of performance, we see a big improvement there. All right, so let's talk quickly. Oh, that's a good word. Quickly about QUIC. QUIC for quick UDP internet connections. Okay, this is the protocol behind HTTP3 in this case. I think we talked a bit about all this. So if we want to do a pros and cons here, it fixed the TCP head of line blocking situation that we talked about earlier, right? If we have a packet that's lost for some reason, we're not going to send everything back. We're going to send only the packet that's being lost. So this is kind of the power of UDP in a sense. Plus, it has a better, obviously, since we can send only the packet lost in internet, where in situations where we have a bad network, this thrives, right? Because obviously this is where it's more often happening. Yes. Oh, okay. Thank you. And so another thing is it's reduced obviously the time to connect, right? It goes from like multiple steps to 0 step now, because if you have a session resumption. But the thing is, like on the cons side, there's a couple things. First, TCP is everywhere, so usually, your load balancers are all happy with it, so there's no problem with HTTP 1 and 2. When it comes to UDP, usually by default, we don't see all the networks having UDP allowed. So you need to worry about this. If you have to turn on HTTP3 in your network, make sure you are allowing UDP connections. And also, there's different implementations at this point. We know that things like this mature in the long term. Even if it's GA today, things like HTTP2, I think even now, there's still people using HTTP1. So it's kind of going to take a time to get to a dominant layer there in terms of implementations. Now, HTTP3 is being used 80% by, like in kind of some data we found, 80% of Facebook traffic is going through HTTP3, and that's about 25% actually of the full internet traffic. That's because basically the big players are already using HTTP3, okay? So all Facebook, Google, all the big companies are already using that. So behind the scene, a lot of the traffic out there is already HTTP3. Now, quick thing. Let's take a look at how HTTP3 is actually configured in Envoy. Envoy supports HTTP3 since Envoy 1.22 on downstream connections, meaning connecting to Envoy. The client can connect using HTTP3 to Envoy. On the recent version of Envoy, by 1.24, now we have support for upstream connections. So from Envoy itself, we can connect to a backend service which is in HTTP3. Now, this is still not fully supported. There's still missing things there, but the GA part is actually from a client to Envoy. Now, other things is, so we need to create a new listener, obviously in UDP for QUIC, for actually HTTP3. Another thing that's really important is that we can introduce HTTP3 without a big problem, meaning we can configure both listeners with the same port, and actually we can use the alt service header in HTTP2 where we can, let's say a use case we have HTTP3 allowed by Envoy. You can send an alt service saying, hey, well, HTTP3 is available on Envoy this time. The client will switch to HTTP2 connection, meaning it's easy to move to HTTP3 in your environment. I'm going to just show you the configuration instead of demoing it. It's going to be easier and faster. I'll take a look here. So here is an example of a configuration allowing HTTP3. So if you take a look at Envoy, I don't know if you guys are familiar with the configurations. Now, the only thing you have to do is to create a new listener with UDP this time. You can use the same port as the one exposed in TCP, and you have to create, add the transport socket to be using QUIC, and then you have to provide the TLS certificate. But in this full example here, we see that we have, again, another listener, that is also on TCP this time, using the same port. And again, as I mentioned, you can use alt service header to let your client know that the same service is available on HTTP3, and the next connection can be HTTP3 to Envoy. Again, this is publicly available if you guys want to check it out. My repo is here. If you have any questions, I can help you with the configuration. In terms of performance, a quick thing here. Performance, we see that, well, HTTP3 is way better than HTTP1, that's for sure. But we see kind of similar performance HTTP2 versus HTTP3 in good networks. Kind of similar at this point. But HTTP3 is way better when, obviously, networks are not stable. I was talking about like packet loss and all this stuff. That's basically the reality of our world already. And also, HTTP3 is really effective into transferring like small files, right? If you think about like a couple files here and there. I want to just jump to the conclusion here. So, in conclusion, HTTP3 works over QUIC, which is based on UDP. TLS1 is embedded within the protocol, so it is always encrypted. It helps the security posture. It helps with all the effectiveness of TLS1.3. It's more performance on low network where packets are lost, and it's already adopted by the big players out there. It's now supported in Envoy, so give it a shot. And again, one of the big things that I like about HTTP3 is the seamless connection switching. If I'm going from a network to another, everything gonna be still working fine. With that being said, this is the end of my talk. Thank you for listening.